We are going to work now on double angle and half angle applications within the trigonometry identities world. So step one, we're going to look at these double angle applications. We're trying to find the sine of 2 theta. We've just derived the formula. We know that the sine of 2 theta is 2 times the sine of theta cosine of theta. So in order to solve this, we need to find the sine of theta and cosine of theta. Well, we were given part of it, right? We're given cosine of theta. That part's easy. All we need is sine of theta. Fortunately, they've given us enough information about theta that we can derive the sine value of it. This is something you've done before. If I know that theta falls between 3 pi over 2 and 2 pi, which quadrant am I in? Bottom right, fourth quadrant. We're down here somewhere. So I'm going to draw a version of it, a terminal side. And all I know is that the cosine is 8/17 here. So that adjacent side is 8. This hypotenuse is 17. If we want to find the vertical component of it, we'd use Pythagorean theorem. 8 squared plus y squared equals 17 squared. 64 plus y squared equals 289. Y squared equals 225. So y equals plus or minus 15. Because we know what quadrant we're in, is it plus or minus 15? It's negative 15. And that tells me that I can find the sine of this angle as what? Negative 15 over 17. I know that the sine of 2 theta is the product of 2 times this sine of theta times this cosine of theta. 2 times negative 15 is negative 30 times 8 is negative 240. 17 times 17 is 289. That's my answer. Negative 240 over 289. Yes. Does this simplify? It's not an even number. Doesn't divide by 3, doesn't divide by 9, doesn't divide by 5, doesn't divide by 7. I think that's good for now. I mean, 17, the denominator is 17 times 17, so it's semi-prime. Doesn't simplify. Any questions on this process for applying the double angle identities formulas? Well, we've been asked to find the sine of 2 theta, but we had to find the sine of theta to get there. Okay, let's move down to the one that's a little bit more interesting. Half angles. We want to find the cosine of 67.5. That's a value we could not have found before. Which of these 5 formulas here do you think we're going to use? Can I go back? Make sure I'm actually recording here. Okay, so half angles. We're going to use this one, right? Because it's cosine. So I'm going to write cosine, but I'm going to leave an open space here. Actually, I should have left that other theta open space as well. Because I don't want to write 67.5 there. I want to express whatever this value is, which is equivalent to 67.5, as theta over 2. In other words, 67.5 has to be replaced with theta over 2. How do I solve for what theta is? Multiply by 2. Cross multiply here, and I get theta is equal to 135. So in other words, I'm going to express this as 135 over 2. And therefore, over here, I get 1 plus cosine of 135, which is a value I can work with. That makes sense to me. So now let's do the evaluation. Plus or minus square root of 1 plus unit circle 135. Cosine is negative root 2 over 2. over 2. Remember when I said you need to know 3 things for this stuff or be able to do 3 things? You need to know the formulas. You need to know your fraction cleanup. How do I clean this up? I'm going to take the numerator and get common denominators. So 2 over 2 minus root 2 over 2, still all over 2. Now I've got 2 minus root 2 on top over a 2, all over a 2. And that's the same thing as plus or minus 2 minus root 2 over 2 times 1/2, right? Dividing by 2 is the same as times 1/2. 2 minus root 2 over 4. Which is 2 minus root 2 on the numerator and root 4 on the denominator, which is plus or minus 2 minus root 2 over a regular 2, and one more step.
The angle is positive because 67.5 is a plug and run.
Excellent. Go back to what you're looking for here. Cosine of 67.5. The original problem was in what quadrant? First, I know we used 135 because that's what the formula told us to use, but the problem is really to find the cosine of this 67.5 angle. Do we expect this cosine to be a positive or a negative value? Positive. So our final answer should be positive 2 minus root 2 over 2. And I know we've got this nested radical thing that looks ugly, but that's the way we're going to leave the answers sometimes. What do you think? 5. Okay, I can do this. 3, as long as I got the formulas in front of me and I work some time carefully on the fractions, I can do this. 1. This will be my demise right now. Okay, hands down? Yeah. Overall, the purple one? Because I looked back at the original problem. If I took the cosine of 60 degrees, we'd know that that's right over here, and it's the x value, and it's going in this direction, so it'd be positive. So the cosine of 67 will also be positive. Okay, please flip to page 2. Let's have you guys try one yourselves. Let's try number 8 down here, please. All right. As I've circulated around, I found a lot of good support. A lot of good work. Okay, so we started with tangent of theta over 2. We have to pick one of our formulas. I would pick one that doesn't have the square roots in it. So maybe we'll do sine of theta over 1 plus cosine of theta. That means to evaluate this, as asked, we have to find the sine of theta and the cosine of theta. Well, we've got the sine of theta. We need the cosine of theta. So I know that if I'm in 3 pi over 2 to 2 pi, I'm again in quadrant 4. Sine is opposite over hypotenuse, so this is negative 12/13. I can do the Pythagorean theorem and say x squared plus negative 12 squared equals 13 squared. X squared plus 144 equals 169. So x squared equals 25. So x equal to plus or minus 5. Because of which quadrant I'm in, this is going to be a positive 5, which means the cosine is going to be adjacent over hypotenuse, or 5/13. So I'm going to have 1 plus 5/13. And now it's just simplifying. So I've got negative 12/13. This is 13/13 plus 5/13 is 18/13. That can be rewritten as this times the reciprocal. So I get negative 12 over 18. That's the same as negative 2 times 6 over 3 times 6. So the answer is negative 2/3. What do you guys feel? 5, this is totally doable. 3, there's some work in it, but I can do it. 1, I don't like this. Good scores. Okay, this should get you going on this homework. This is 68, double and half angle formulas.